Fans of this channel will know that I absolutely love to find brand new, fresh Flat Earth content. A chance for me to get stuck into some new and fresh Flat Earth content that I've never seen before. I'm joking, of course, it's all been seen before. But Todd Peachy thinks he's different. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin today, a quick thank you to the sponsors of today's video, YouGov. I have found a brilliant easy way to earn cash just by sharing your opinion. With YouGov, you can take online surveys to earn points and then get cash rewards. YouGov has surveys about politics, social issues, your favourite brands, sports, public affairs, products and celebrities. For example, right now they've got surveys about unemployment, climate change and a whole lot more. It's free to join, and as a member you'll earn points for completing their surveys and answering questions via their website or app. You'll earn points for completing your first survey, plus you'll get rewarded if you recommend YouGov to your friends and family. And you can exchange your points for a £50 cash payout. Of course, I've tried this and I'll be using that extra income to fund my next science-based tattoo. Click the link in the description box to start making money right now. Right, back to today's video where we're taking a look at one Todd Peachy, who is a flat earther that I've never heard of before. Now, granted, his content is from 2018, but I haven't seen it yet, so I'm itching to get stuck in. Here we go, and we start with a video of his on gravity.
Okay, science tells us the estimated weight of the oceans is 1 quadrillion, 450 quadrillion short tons, okay? A short ton is 2,000 pounds. So that makes the ocean's weight 2 sextillion, 900 quadrillion pounds.
For those of us using the metric system and scientific notation, the estimated mass of all the oceans on Earth is around 1.35 times 10 to the power of 18 metric tons.
That's the ocean's weight. Now, gravity is holding all that weight in, but it just really struggles with refrigerator magnets. It just, oh, there it goes. Now gravity's got it. Here, hold on. Oh, no, I'll help gravity here. It can hold down sextillion. That's a lot. That's a bunch of zeros. So it's, oh, there it goes. Oh, jeez, oh, man.
What's Todd's point here? A fridge magnet uses magnetism to stick to the fridge. It's a force that not only counters, but is vastly stronger than gravity. The oceans have no mechanism of fighting gravity. They just are.
Why isn't it pulling those refrigerator magnets down off my refrigerator? Why does my refrigerator have more power than gravity that can hold in sextillion? See that my refrigerator is pretty, see it's holding that one on there.
Because if you knew anything, Todd, you would know that the gravitational pull between two objects relies on the mass of both objects. Your fridge magnet is teeny tiny compared to the entire mass of all the oceans.
Yeah, there we go. See, now, if gravity can hold all the weight of the ocean in, don't you think it's going to have a pretty easy time with these refrigerator magnets? I mean, it just seems like it would. If it can lift sextillion, that's a lot of pounds that holds in. Huh. Something to think about. Something to think about. Boys and girls, I think it's time that we consider that mass has weight.
And what do you think it is that causes mass to have weight? Think about it really hard, buddy.
Okay? Gravity doesn't hold the oceans in. The oceans sit down because they're heavy.
The oceans are heavy because they have a huge mass. A mass which, when multiplied by the gravitational acceleration of Earth, gives them a huge weight.
This pen is heavier than air because air's got mass, but this pen's got denser mass. It has weight. So does air. Air has weight too.
Yes, because of gravity.
Air has weight too, but this pen just has a little bit more weight. Okay?
He is so close to understanding, he just can't connect the dots.
It's just time to really look closely at the lie we were taught. It doesn't make sense. You can tear it apart anywhere you want. It doesn't make sense. Gravity, holding planets in an elliptical orbit, a ball of burning hydrogen. Jeez.
Your personal incredulity isn't a good enough reason for you to doubt the sun, Todd.
And somehow that's heavy enough to put a dimple in space-time. A ball of burning hydrogen is keeping all these planets, some of them that are millions of miles further away from the sun than us, and elliptical orbits. I won't even go into it.
Probably because you don't understand it.
It's like, come on. You know, what is the sun doing? So it's like, oh, it's taking off this giant elliptic orbit. It's like, oh, at the last minute it catches it, turns it around because it's putting a dimple in space-time, and it's like sitting in a giant bowl while it's traveling 450,000 miles. While we're chasing it, we're all sitting in this bowl that chases along with it, I guess. Einstein was a fraud and a crook.
Wow, getting a bit heavy here, Todd. Perhaps we should move on to something else. Now, what else has Todd done a video on? Let's have a look. Here we go, a perfect video entitled Scientists Don't Know. Here we go.
Hey everyone, just a quick video tonight on the composition of the Earth. We're going to take a look at what science says our Earth is comprised of. We've got our different layers. Let's look at those first. We've got our tectonic plates, and then this first layer would be the crust, the mantle, the outer core, and the inner core. Okay, so what are those made of? Okay, the crust is the tectonic plates. They didn't really define that in the article I read, and it's not important to what we're looking at here. Okay, after the crust, we've got the mantle. The mantle is made of silicon, iron, magnesium, aluminum, oxygen, and other minerals.
Okay, so we've got a diagram of Earth's interior here, and Todd is going to do what exactly? I reckon he's going to go through all of this, and then at the end he'll say, and how far have we drilled down?
Okay, the inner core, or excuse me, the outer core. The outer core is liquid nickel iron alloy. Okay, it's a liquid. And in the center of that is a ball of iron. So we've got an iron ball, a liquid nickel iron alloy. We have the mantle, silicon, iron, magnesium, aluminum, oxygen, and other minerals. And we have the crust. Now, how do scientists determine these properties?
Excellent question. Let's see what Todd says here.
Well, let's take a look at some things. The furthest we've ever drilled down any hole on the whole planet, the furthest we've ever drilled down is 7.5 miles.
I knew it. I knew it. So predictable, our flurfs.
Okay? We didn't even make it to 8 miles. We've drilled down 7.5 miles. Doesn't make it through the crust. The crust is 18 miles to 30 miles thick. But we better check at the ocean. At the ocean, the crust is as little as 3 miles thick. But there's the water too. So how far have we drilled down into the ocean floor? Oh, it looks like 1.48 miles to drill for oil. The crust is estimated 3 miles. I'm going to say estimated. Okay. We've never been through the crust, folks.
And to be fair, we've never stated that we have.
Now, here's how NASA says they determined all this information. And I really like the liquid moat around the iron ball. That just fascinates me. Using waves emitted by earthquakes, scientists get a sense of the innards. That's straight out of the textbooks. That's right, read them and weep. Waves emitted by earthquakes give scientists a sense of the innards of the Earth, of course, not their own innards. They should spend more time with their own innards. Okay, now they have also used seismological and magnetic field data along with, okay, so they can't just use that by itself. They have to use that along with theoretical calculations. You can interpret that in a lot of ways, but I'm just going to go straight with theoretical. As it stands, theoretical. Theoretical.
You don't have to keep saying theoretical. What Todd fails to realise here is, of course, there are thousands of scientific peer-reviewed papers on the composition of Earth's mantle littered over the internet. Now, he wouldn't make this video without reading at least one, would he? Would he?
So seismological and magnetic field data along with theoretical calculations. So they've taken lines like this and maybe magnetic field lines, and they can tell by that into a land that they've never seen, the inside of the Earth. They can tell all these wonderful things.
Yeah, Todd, they just looked at the lines and then made it all up. Of course they did.
Bouncing signals around and listening to earthquakes. Like, how does that sound, Pete? That earthquake was pretty big. It's like, what can you tell by that? Well, I'm thinking that the core of the Earth has a liquid outer core that's made of liquid. It's nickel and iron, I think.
Now, Todd is obviously taking the mick here, but this is a thing, of course. Seismic shadows are excellent evidence for both a solid inner and liquid outer core. As you can see here, the P waves and S waves from an earthquake pass through different mediums differently, We can infer from this the composition of the centre of our planet.
Well, let's look at the data. Are you sure about that? Well, it doesn't bounce back right away. What does that tell you? I don't know. It's theoretical. Okay? Nobody knows what's in the center of the Earth, folks.
This is a patently false statement. Of course we do.
Scientists don't know, but look at all the bullshit they're going to feed you. Okay? They're looking at lines and data, making guesses, admitting to being theoretical. They get a sense of the innards. That's a pretty weak. Are you sure? Well, we get a sense of it. And theoretically, we think we know. No, nobody knows. You know what's in my hand right now? It could be anything that fits in my hand, out of anything that you know. But what if it's something that you don't know? What if there's some other element that you've never seen? It would take you forever to guess what's inside my hand.
Well, we could X-ray it and then find out immediately. We laugh and we joke, but of course that's my point. We look at the evidence using the tools we have.
You can bounce all the signals around you want, and you can compare those to how signals bounce off of other stuff that you know. You'd have to test everything. There is no way to know. It's like trying to reverse engineer a cake. Okay? Are you truly going to come up with an egg in a shell? Are you going to know that part of it was discarded, the shell? Are you going to, after you've baked it, are you going to be able to tear that apart and know that an egg was used? Are you ever going to be able to figure that out?
Well, yeah, because we know the recipe of a cake.
No, you're not. Some things cannot be reverse engineered. Some things are truly above science. The core of the Earth would be above science. That would be one of those things that they just don't know.
I personally think that there isn't anything above science. Now, sure, we currently don't have the scientific understanding or abilities to figure some things out, but I won't say that those things are forever out of reach.
But they sure act like they do. Now, I've got something in my hands. Can you guess what it is? How long would it have taken you to get this? I've got air in my hands. Air has mass. I have something in my hands. I grabbed a handful of air real quick. Boom.
Fascinating that people listen to this man. Well, there we go. A fantastic Flat Earth Friday video there on Todd Peachy and an excellent case of Dunning-Kruger. Now, he does have more videos, so we could go back and revisit him at some point. What do you think? But for now, we're all done and dusted. Thank you so much for watching. If you really enjoyed it today, please do consider subscribing. It'd be thoroughly appreciated. And please do like the video as well if you really enjoyed it. It all helps. Just enough time to once again thank YouGov for sponsoring today's video. Remember, click the link in the description to start earning money today. I've been Simon Dan. Thank you so much for watching. And I'm now going to take my 2-week break. And next week, next Tuesday, we have the first of our guest content creators, The Skeptic. But I'll see you at the beginning of that video briefly. See you then.